Hello, everyone. You are welcome to today's meeting. And in today's meeting, we'll be looking at bearings. Okay, bearings. And bearings and vectors are connected. So usually you see vectors and bearings. Okay, but we have treated vectors, and now we are going to look at what? That of what? Bearing. Okay, so quickly, let's look at the introduction. But before the introduction, let me walk you through the lesson objectives. So by the end of the lesson, you should know what a bearing is or bearing angle is. Okay, you should know how to draw diagrams based on bearings. You should be able to determine the types of bearings. Okay, you should be able to draw diagrams based on bearing with 3 points. We'll look at 2 points and 3 points, ideally. Okay, and last but not the least, okay, you should be able to deal with front bearing and back bearing. Okay, so you should move from front bearing, okay, to back bearing and vice versa. Okay, so quickly, let's look at, okay, the definition of what? Of bearing. A bearing is basically the angle in degrees measured clockwise from the north. So it's usually measured clockwise, that's the direction. And its baseline is always what? The north. Okay, so bearings are usually given as a 3-digit bearing. Okay, and 3-digit bearing is a special type, or it's a type of what? Of bearing. We'll come to that. But because usually we deal with a 3-digit bearing, this kind of bearing. Okay, that's the more reason why I use that one in my introduction. Okay, so for example, if the angle is 60 degrees clockwise from the north, when you are writing it as a bearing, it becomes what? 060, okay, degrees or 060 degrees. Okay, so therefore the bearing of a point A, okay, from a point B, and from bearing, anytime you are dealing with bearing, you should have your reference points. Always. If you don't know your reference point, it will be very difficult for you to, okay, deal with what? The bearing. So the bearing of a point B from a point A, so it means your reference point is A, is defined as the angle of the clockwise turn on the ray. So this is your A, this is your B. So you are moving from A, okay, to B. But remember we said the bearing of B from A. So you are at A, you want to locate what? B. The bearing, which is the angle, will only, okay, make it possible for you to sight B. But it will not take you to B. You can only see B, okay, but you cannot get to B. You can get to B when you are given the distance. Is my point well made? So the bearing basically will be the angle that you have to move clockwise from the true north to sight your object, okay, or to sight your destination. Okay, however, together with the distance, then it will take you to your destination. But I'm talking about the bearing here, not the distance. Okay, so here in this diagram, what we have here becomes the bearing. The angle from the true north to the line joining your 2 points of interest, which is A and B. So we are going to get what? This to be our bearing. Okay, this angle here. So I can call this maybe theta. So this is the bearing that we said, okay, angle in the clockwise turn on the ray AN to the ray AB. Okay, so AN to this. So this becomes your bearing. And your bearing angle can be in any of the quadrants. Please take note. Okay, so if my point is well made, let me quickly move on to the types of bearing. There are 2 main types of bearing. The true bearing, which is the one that we usually use. I will be very brief. Okay, and that one is the one that usually you state it in 3 digits. Okay, that's a 3-digit what? Bearing. And for the true bearing, your angles can be acute. Your bearing angle can be acute, it can be obtuse or even reflex. The angle that you measure, and you know that the angle will be measured from the true north. Always the true north is what? Your reference if you are dealing with the true bearing. Also, yes, the true bearing. Okay, so take note. So for example, like I said, okay, 40 degrees angle from the north is a bearing of 040 degrees. And we have another type, which is the compass bearing. You know our usual okay, not theta degrees, okay, maybe south, sorry, east. So usually you will see this. This will be the nature, north, okay, your angle, okay, then maybe east. North, your angle, then maybe west. Okay, and south, your angle maybe east. Okay, then south, your angle, okay, then west. Usually the reference point will be either the north or the south. So it is north, you move a particular angle towards the west or the east. South, you move a particular angle towards the west or the east. Okay, however, with the compass bearing, your angle theta should really be acute. It cannot go beyond 90 degrees. Please take note. It cannot even be 90 degrees. Usually we say that it should be acute. And I think I stated it here. The angle must, okay, be an acute angle. So you can say that this angle here is acute. So the true bearing that I've stated here, a corresponding compass bearing is this. Very soon you appreciate this concept better when we start drawing and bringing out. So this is just the introduction. Okay, so let's look at, okay, how to draw, okay, diagrams based on distance bearing. Okay, you will need this. Okay, once you get this, every bearing question should be easy for you because always the diagram that will be key. If your diagram is wrong, everything will be wrong basically. Okay, so please take note. So quickly, let's go and look at the solution to this question. So draw diagrams to illustrate the distance bearing of. Okay, so this is the distance, this is the bearing. Okay, so indirectly what we have here is a vector given in the magnitude bearing form or the distance bearing form. Okay, so here, if you look at, we said S from T. So our reference point is what? T. Okay, so I'm going back to the normal view because I will need, okay, the straight edge. Okay, so this is what we are supposed to have in terms of our presentation. Okay, so let me pick my straight edge. Okay, now in any time you are dealing with bearing, okay, please take note. You must always fix what your cardinal point. In this case, I am more interested in the north. As for the west, the south, the east, okay, that one, if you are dealing with a true bearing, you can ignore. But for the compass bearing, you cannot. So I am going to look at this to be in the true bearing form because if I look at my angle here, the angle is in the bearing form, the true bearing form. So now what do? I go and, okay, draw. So let me draw my, but before you draw, picture the situation. Okay, get a rough picture. Here I can see that because sometimes if you don't get a rough picture, okay, you will start drawing and along the line, you know that you have to push your point or maybe your lines, okay, to a certain area. And that will be a waste of time. So just take a little time, think through, okay, the situation, get a rough sketch of the situation before you go and do the main sketch. So here's solution A. Okay, let me change my marker. I think it's black. Okay, so A. Okay, we are going to, we know S from T, so we are going to draw. But if you draw, you see that if I look at what I have here, my angle, okay, my bearing angle, from here to here, we start from the north and we measure clockwise. So this will be 90, 180, 270. But I'm looking at what? 330, and that will be between, okay, 270 and the 360 or the 0 degrees. Okay, so it means my line is going to be here. So on that note, when I'm drawing, okay, I will come down and move my diagram to the side. I mean, where I will place my cardinal point so that I will get a better picture of the situation. So, or the best picture of the situation. So in this case, I'm going to do this. I will draw, so I've drawn indirectly my west-east line or east-west line. Then I'm going to indicate that of what? My north-south. So this is going to be the situation. Okay, so immediately I do that. Remember I said, okay, your cardinal point of interest will be the north. So I will equally go and indicate what's that. Okay, so I will do this. then indicate what's the north there. Okay, now let's look at the angle. The angle is what, 330. You are not going to use any instrument to measure. Okay, you are not going to draw to scale. However, your picture should be very close to the situation, meaning it should make sense. So if I look at this, I'm looking at 330. So I will measure this angle here from the true north. This is 90, 180, 270. 330, I need how many more to get to size of angle that I need to add to 270 to get to 330?
60.
60. Okay, so look at this. I know that 60, if I'm looking at the 60, this becomes my baseline for 0. So 60, so my 60 degrees line that I'm going to draw here, okay, should look closer or should be closer to the north line than to the west line. I hope you get my point, because though it's not drawn to scale, I cannot come and do this. Okay, draw this way. Okay, fortunately for me, my ruler can give me the angle. Okay, but I'm not going to depend on that anyway. Okay, you will not have that situation. So assuming I come and do this, and I write the angle that you add will be the angle that indicates. So I add 60 degrees. Yeah, I write 60. Let me move this one here. So I write, okay, where is my, okay, so I write 60 degrees. Okay, is this making sense to you? Is it? Obviously, no. You can see that this line here, if midway will even be 45. Now you've not gone beyond the midway, and you are saying that this is 60. How can this be 60 and this will be 30? So the fact that you are not drawing to scale doesn't mean you should just draw anything. Please take note. Is my point well made?
Yeah.
Okay, very good. So at this point, this will not be the right way to go. Okay, so bearing is all about you getting the true picture, taking into consideration your angles as well as the distances. That's all. If you're able to get this, okay, the rest should be very easy for you to relate. Oh, I mean, the normal views, I can even go back. I've forgotten. Okay, so now this is what we have, and this is what we are going to do. Okay, so we know 60 should be close to this line than to that. Like I said, and my straight edge can give me a better picture. Okay, so this is what I have. My ruler is giving me the 60. Okay, exactly. So here, I was giving the distance. I'm not drawing to scale, so I can go as far as possible. But it doesn't really matter. You can even make it short, because we are not comparing it to another distance. So you end here. When you end here, you indicate your initial point, where your reference point, and we said S from T. So your reference point would be what? T. And where you want to get to, okay, your point of interest in terms of your destination sort of would be S. Okay, and now you know you added this angle 60. You have to indicate the added angle. That's the angle of interest that you add. Okay, then after that, what do? You indicate, okay, your distance, and the distance here is 12 km. All correct. Is my point well made?
Yes.
Yes, please.
Very good. All right, great. Okay, so I'm going to do same for the B. Okay, then maybe the C you will try later. Okay, you know we are behind time, sort of. Okay, so B, we are looking at Q from P. So you know you have to get these 2 points indicated some way, somehow. Okay, then, okay, the bearing angle is what? 80. Okay, so 80. So it means, what do? I'm going to draw. The rough picture will tell me that my angle, so my rough picture, my rough work, okay, my angle 80 will be in this quadrant. So I will need this side, okay, more. Okay, so what do? I will start drawing my line from here. Okay, the line that I will need. So it will go this way. So I'm going to do this again. Okay, my north-south. Then I come and indicate my, okay, let me calm down a little. Okay, my west-east or east-west line. Okay, so remember what you need to indicate will be your true north, very critical. Now, look at this. With this one to the bearing angle, so your reference point here, the point that you are going to indicate here, because the line is going this way, don't indicate your point here. Because your line, avoid as much as possible. Don't let your lines intersect or interfere with your point of interest. So here, one of your points of interest is what? P from P. So I know my line is go this way. So either I label my P, here I put my P, here I put it here. But I cannot be here in the same quadrant. So now I'm looking at 80. So 80, remember, I am moving from this line, this particular line that we have here, to measuring in this direction. So 80, this is my 0 line. 80 will be closer to this line, okay, than this line. Do you agree? Because midway is what? Is 45. So 80 must go beyond the midway. Take note of that. Okay, so if you draw it anyhow, which it will look, immediately it's obvious that it has not gone beyond the midway. It means you are not bringing out the true picture. So my 80, like I said, I am very lucky. Okay, I can get so if the whole of this is what, 90, and I'm looking at 80, then I think I can get, okay, when I get 10, that will be okay, but you are not measuring. So let me assume I cannot see the figures there. So 80, it should be very close to that line. Okay, so I come and draw my, okay, line. So this then becomes, okay, the line of sight, okay, for my point was Q. Okay, so assuming Q is located somewhere here, okay, then the distance between P and Q, you are told is 10 meters. So you indicate your 10 meters. All correct. Is my point well made, my professors?
Yes, please.
Great. Okay, so that will be it for the diagram situation. Now let's go and look at what the next, okay, set of questions. So now I'm done. So I can, okay, disable my ruler, go back to my presentation view. Okay, so this is what we have. Okay, so we are going to look at what? Moving from the compass bearing, okay, to the true bearing, and from the true bearing to the compass bearing. If you know how to deal with these two, okay, again, you should be well grounded when it comes to vectors questions. Bearing questions. So take note. So in this situation, you can see we are supposed to find a compass bearing of the following. Compass bearing of the following. And you can see that what you have here are the true bearings, okay, respectively. So now let's go and look at the solution. Okay, so compass bearing. Okay, so we need to get the diagram for the true bearing that you have there. That will help us get what? The compass bearing. So in this case, A. Okay, I think I have to go back to that view again, because anytime you are drawing, unless it's a rough sketch, okay, your drawing, please make sure you use a straight edge. Anytime you are drawing a line, a circle, use the appropriate instruments. Take note of that. So in this case, oops. Okay, so let me go back to my normal view. Okay, so this is what I have. So I need to draw before I can get the compass bearing form of what we have there. So let me again pick my straight edge, okay, my ruler, then I go. So I'm going to draw 0, 40 degrees. So that will be in the first quadrant. Okay, so I'm going to have this as the picture. So indirectly, this is what you are giving. So I'm going to draw. Okay, and very soon you can easily determine that without drawing. Okay, so we are going to get this. Okay, so let me calm down a little so that I will have room there for it. My area of interest is this region. So that's where I should have. And you don't forget to indicate your true north. So here you are looking at what you measure 40 degrees. So 40 degrees, okay, midway is 45. So 40 degrees, you know, should be closer to the north than towards to the, what do you call it, west? Sorry, east. Okay, so in that case, assuming this is my 40 degrees. It's looking like midway, so let me move a little. Okay, so assuming this is my 40 degrees. Interesting. Okay, so I will draw it. Okay, so I'm going to get what I have here. So this is the situation here. You were not given any point. So just the bearing. So the bearing here is your 40 degrees. When you are indicating, you don't add what? The 0. So this is the bearing. Okay, in terms of the true form. So the true bearing. Now, when you are dealing with what? Because you want to move from the true bearing to the Cartesian. Did I say Cartesian? Okay, Mr. Akwal is tired. Okay, so from the true bearing to the compass bearing. Compass bearing, you have to, okay, know all your cardinal points. So we have our west, you have to indicate, okay, our east, then what's the south? It's very critical. Okay, so for the compass bearing, you know that usually your reference point will either be the north, okay, or the south. So it will be north or south, moving towards east or west. Okay, as you saw in the note. So in this case, this is what we have. If I'm looking at this, okay, I can see that I'm moving, I'm starting from the north, okay, and moving in a particular direction towards what? East. So that will give me, okay, I'll write therefore, okay, my 0 for 0 degrees will be equal to, in terms of what? The compass, it will be north by angle that I moved. You can see that the angle we said should always be acute. And that angle is 40 degrees. Okay, and you are moving towards the east, and that would be what? East. So it will be not 40 degrees east. Is my point well made, or I should come again? Please, is my point well made?
Please come again.
Okay, all right. So this is it. Okay, you can see your card immediately the compass bearing comes in, then all your cardinal points must be indicated. Okay, so let me make it a ray. Okay, it's because that is in actual fact what you are supposed to have. Okay, so the arrows, okay, should be there. Okay, so I'm saying that with this one, anytime you are dealing with what's the compass bearing, okay, your lines will always be in either this quadrant, okay, this quadrant, or this quadrant. Anywhere that your line will be located, it's either you see north or you see south. Okay, and you always have to start with what? The north or south. Then you look at the angle, you move the angle towards either east or west. So if it is here, I can say that it is north and I'm moving towards east. Okay, if it comes here, it will be south. Okay, and south you move towards what? East, because it's between south and east. If it is here, it will be south and you move towards west, so because it's between south and west. If it is here, okay, you know, north and west, so you always start with the north. So it will be what? North, okay, you move a particular angle towards what? West. That is usually the situation. So if I'm in this quadrant, I'm going to look at what? North, okay, moving a particular angle towards what? East. So north will be your reference line, and you are moving an angle. So the angle that you move from north to get to this line of interest is 40. So it will be north, I move 40 degrees towards east. Is it clear now?
Yes, please.
Okay, so that will be it for A. Now let's look at that of the B. Then maybe, okay, the rest you can deal with it, okay, later. So I'm going to look at maybe B will be, let me see, that will be, okay, so B is going to be in this quadrant. So that's okay for me. 2, 9, 5. So that will be in this quadrant. It will also be, okay, in the, okay, it doesn't really matter. I will still make my point. So B, let me go and draw the picture. So B, okay, my angle here will be between 270 and what? And 360. So obviously I know I will need the side more. So I'm going to draw, okay, by looking at the size of my angle. I know exactly what to do. So I will have this picture. Is this picture that I will be looking at? Okay, and after drawing, because I will be looking at the compass bearing, okay, I won't forget to indicate my cardinal point. It is very important. So let me calm down a little. Okay, so this is what I have. I need the side more because that's where my, okay, angle will be. So at this point, we are good to go. Don't forget, okay, when you are drawing because of the true north, the true bearing, you indicate, okay, the north only. But now you know that you need the compass bearing. So that will imply that you have to indicate the other cardinal points. And like I said, this will be raised. Okay, and you can see anytime you see that, you see arrows there as well. So we are looking at what? 295. So 295 will mean here, I know here is what, 270, am I right? So I will need how many more to add to 270 to get 295?
25.
25. So 25, you know, now this is your baseline. 20, you are moving 25, okay, upwards. So 25 will not even go beyond your midway line, which is the 45 line. So it means 25 should be closer to west than to the north. Is that clear? You are not drawing to scale, but remember, okay, it should make sense. So my line that I'm going to draw to represent 25 should be closer to this one. Okay, so this is what I have. So I'm going to draw that, and that will be very useful. Oops. Okay, so it's just that line. And the angle here that I added, I need to know its side. That's a 25. Very important, 25 degrees. Okay, now this is the picture in terms of the true bearing. Okay, so let's go and make the determination in terms of what? The compass bearing. So in that case, my true 95 degrees will be equal to, you can see that this line is between north and west. Okay, so you have to write your north. It will be between north and west. And a certain angle must come between them. But you can see that here, you cannot write 25 because if you are moving from north, you move in this direction. So you said it will be north, then you move. So it is this angle that you are interested in terms of the compass bearing. Is my point well made? Okay, north, what is the angle, or what angle should I move, okay, to get to this line in the west direction? And that will give me, okay, I subtract this from this one from what, 90, and that will give us
75.
okay, 75. So on that note, we are going to get, okay, 75 degrees. Yes, yes, please.
The 25 from the 90.
No, will you get, are you sure you get 25?
65.
It will be 65. 25 will give us 100 if you add. Okay, so who said,
Sorry.
be careful. All right, okay. So 65 degrees. Is my point well made now?
Yes, please.
Yes.
Okay, so with this, you should be able to do, okay, the other ones. Okay, well, I think the other two would be south. So let me draw the 120, then you get one of the souths, then at least I know you are fully covered. Okay, so C. Okay, I'm looking at 120. 120 will be, this is 0, 90, 120. So 120 will be, yeah, so I will need, I know the area that I will need more. So no worries at this point. Okay, I come and draw, I will need the side more, okay, because it will be here. So I am going to indicate my true north there as well. Okay, and I will come and fix mine. So don't forget, because originally you needed your true north. Now, because you know you need a compass bearing, you need to indicate your other, okay, cardinal points. So east, then south. Okay, so 120, this is 90. 90, you need how many more to get to 120? And that will be 30. So from here to here, it's 90. So if you need 30, the 30 degrees, okay, line should be closer to the east than to what? To the south. Because remember, we said midway would 45. So that should be closer to this. Is my point well made? So this is where my, okay, the angle that I added, remember I said any angle that you add, you don't forget to indicate that angle. Very important. So here he added 30. So I'm going to indicate the angle that I added. So it means my bearing would be, in terms of the true bearing, it is from here up to this. But I'm looking at what? The compass bearing. So in that case, it will be therefore my true bearing, which is what? 120 degrees, will be equal to. Who can help? I want someone to help. Then I will be convinced that you've understood this concept. Hello, who can help? I want someone to help quickly. Remember, it should always be south. It will be between two. Oh, sorry, why did I write north? Let me go back. Okay. So it will be, okay, south. Okay, it's between south and east. Okay, so your east. What you need is your angle. And remember, your reference point would be what? Would be south. So south, you have to move a particular direction, okay, towards, okay. So south, if you move in this direction, you know that the angle here would be what? 60. So because this is 30, so it will be 60 degrees east. Okay, so probably, okay, you are right. Okay, so 60 degrees, okay, east. All correct. Is my point well made?
Yes, please.
Great. Okay, so now let's go and look at our next question. Okay, so work the example 2. We are going to look at, okay, how to go back. Okay, so in this case, we've been given the compass bearing and we are asked to find the true bearings. Okay, so quickly, let's go and have a look at that one too. Okay, all right. So let's see. Okay. Okay, and again, we need to draw. Okay, however, I am going to explain because I don't want to draw again. Okay, because we have, okay, you let me draw for you to get it. Okay, so A, 2A. The other one, I don't remember writing 1. Let me go and check because numbering is very important. Oh, there wasn't even 1. Okay, it should have been 1. Okay, but there was no question number there, so you maintain it. I cannot introduce my own question numbers. Okay, so now let's come to the 2. Okay, so 2A, what are we giving? You've been given your north, okay, 40 degrees east. So we are going to draw. Okay, so that one too, you know. North, you move towards what? East. So you should know the picture at hand. Okay, so yes, compass bearing. So immediately I draw, I have to indicate all my cardinal points because the original bearing is what is in the compass bearing form. Okay, so this is what I have, sort of. Okay, so I don't forget my arrows, okay, bringing in the rays. Okay, so my north, my south, my west, okay, my east. So this is what I have. So now what do we do? From what we have there, it's not you move 40 degrees towards east. So the angle between the north, okay, and your line of interest will be 40 degrees. Okay, it should be closer to, because midway is 45, it should be closer to the north than to the east. Okay, take note of that. Okay, so on that note, this becomes the picture, okay, at hand. So the angle here is 40 degrees. Okay, this angle. Okay, now in terms of the bearing, the true bearing, you know, from the true north, you measure in this direction. Okay, so you write there for your north, okay, 40 degrees east, okay, will be equal to, when you measure from the true north clockwise, we are going to get the angle here to be 40 as well. However, in the true bearing, the angles must be 3 digits, so it becomes 040 degrees. Is my point well made? Hello, my professors, is my point well made?
Yes, please.
Okay, great. So with this, I think you should be able to relate with what's the rest. This one to you draw, it will be the same. You are going back, so it will basically be the same. You measure in a clockwise, okay, direction from the true north. So let me do maybe the B. Okay, maybe to open or unlock a certain, okay, issues. So now let's see, 75, still I'm looking at north 75 west. So the line that I'm going to draw must be between the north and what and west. Okay, however, I will know my angle will be measured, okay, from the north in that, okay, west, okay, direction. So let me equally do that here. So, oops. Okay, so now I am going to draw my cardinal. We'll come down a little. This is the picture of the situation at hand. Okay, so now, although I don't forget my north, south, okay, west, then east. Okay, so no, you know that between north and what and west, 75. So north, you move 75 towards what? West. So 75 degrees line will be closer to the west than to what? Because you've gone beyond the 45, which is the midway line. So if you are drawing it, this will become the picture, sort of. Okay, now you know this angle here is the angle, okay, 75 degrees. Okay, so this is the angle. However, when you are dealing with the true bearing, remember we said for the true bearing, your angle is measured from the true north, so this ray, up to your line of interest in the clockwise direction. So in terms of the true bearing, I'm looking at this angle. The angle, okay, moving from here up to this line. Is that clear? Is my point well made, my professors?
Please come again.
Okay, we said for the true bearing, okay, your angle must be between your north, okay, that's the true north, and your line of interest in the clockwise direction. You get it? So, and you know that angles are formed between two lines, is that not it? So if I'm looking for an angle, I need to first of all find my lines forming that angle. And here we said the angle must be between your true north line, okay, and what's your line of interest, which is this. Okay, but in the clockwise direction. So you are looking at the whole of this angle. So from here, the true north up to where your line of interest is. So this angle, but you know that from here to here is 90. Here to here is 90. So it means overall, this is what? 180. From here to here is what? It's 90 as well. So that will give us 270. We need this small angle and we are good to go. Then we know the size of the entire angle here. Are you with me now?
Yes,
Okay,
please.
so it's good I solved this question. So therefore, I will say that my north, okay, 75 degrees, okay, west will be equal to, now you know, 270, you know that this angle would be what? 25. So that will give us what? I'm waiting. 295 degrees,
285.
right? Okay, so 295 degrees. And you can see that we are going back. So we have to get the exact, okay, angles that we have there. These were the compass bearing that we had for the true bearing. So we are going back to see whether we get the corresponding true bearing. Is my point well made? Yes, come again.
This is 285.
No, how come 285? This is 270. And this will be 25.
It will be
No,
15.
it will be 15. Okay. So please, okay, it will be 285. It will be 15. So 285. Is that clear? Okay, all right. Thank you. Okay, so that will be it. Forgive me. It wasn't intentional. Okay, so now I think we are fine. Moving from true bearing to compass bearing and vice versa, we should all be okay. So at this point, I'm going to move on to the presentations of view. Okay, so we are done with this. Okay, let me see whether there is any question at the background. Okay, so now we've corrected that. Thanks for your information. Okay, so let me see whether I did that in the diagram. Okay, so let me indicate that this will be what? 25. It means you will need it. Okay, so at this point, now we can move on to our next concept. Yes, please.
Is 15.
Hey, Semo, I don't know why. I'm still writing because if you add this, you get 100. Okay, 15. Okay, thank you. Okay, all right. So let me do the needful. I always have to. Okay, clear. Okay, so let me clear that. Okay, so that gives us the 15 that we are looking for. Okay, all right. So, okay, all right. Okay, so this is what we have. So at this point, okay, we are moving on to our next concept. Okay, back bearing. This you need to know. Sometimes in certain bearing questions, if you know the concept of back bearing, when you are finding the bearing that you are asked to find, it will be very easy for you. You can handle it from the back bearing perspective to make your work very easy, and very soon you know. So if theta is the bearing of B from the point A, so it means this theta that you are giving is what we call the forward bearing. So any bearing that you are giving is the forward bearing. Okay, if you want to go back, then we call it the back bearing. So if I move from A to B and I move through a certain angle before I go to B, that is my forward bearing. However, if I get to B and I want to go to A, I also have to go through a certain angle before I can locate what A and maybe walk the distance between them to get to the exact place of what A. And when you do that, we are talking of what's the back bearing. So if theta is the bearing of B from the point A, so in this case, your reference point is A, then the bearing of A from B, so you can see that we swap. Okay, your 2 points is what we call the back bearing. So that is the bearing of the line measured in the backwards direction. Backwards direction. So you are going backwards. So that's why we call it what? The back bearing. Okay, or the front or forward bearing. Okay, which will be the one that is given. However, please take note. This is how you move from the forward bearing or the front bearing to the back bearing. Okay, so if your theta and the theta that we have here is the forward bearing, so anytime you see this will be the angle that is known. So your angle that is known, which is the bearing angle, becomes the forward bearing. So if your forward bearing angle is less than 180, okay, then your back bearing will be equal to your theta, which is your forward bearing angle, plus 180. So if your angle is less than 180, just add 180. It will give you the back bearing. Okay, and if your angle is greater than 180, subtract 180 from the front bearing angle. As simple as that. We can use modulo as well, but I think this one is okay. So once you relate with this, usually will not restrict you. So once you can relate with this one, it's fine. And let me use this one to drum home my point. Please, do you get the concept that I brought out here? So how easily you can get your back bearing knowing your forward or your front bearing. Okay, so this is it. So assuming this is it, I'm looking at this to be my front or forward bearing. The bearing of what B from A, which is 130. Now, if I want to get the back bearing, and the back bearing will be the bearing of what A from B. You get it? You swap. Is that okay? Please, my professors, are you following?
Yes.
Okay, great. So now if that is the case, this is what we'll be looking at. Remember I said ordinarily we should have true not indicated. True not indicated. Okay, so let's see. You know the value here. Now, how can we get this value, which is the bearing of what A from B? And we said this angle here, which is your, so in this case, your theta, okay, is equal to what? 130, is that clear? So this is
Yes,
your forward bearing. Let me use FB to represent that. So your back bearing, we'll deal with specific example. Okay, this is just the introduction. So your back bearing, okay, will be equal to, remember we said if your theta is less than 180, you add what? 180 to it. So you are going to get 130 degrees plus what? 180 degrees. And what would that give you? 310 degrees, am I right? Am I right? Okay, which is exactly the case here as well. So you can see, this is the bearing. So if you are looking at the bearing, okay, of what, B from A, meaning I'm standing at A, the true north at A, I measure an angle from the true north up to the line joining my points of interest A and B. So this is the angle, and you are told that the angle here is 130. So if I want to get the back bearing, then it means this time around I have to stand at A, measure my angle from the true north up to this line. Okay, and that will give me, remember, indirectly, okay, I can do this. I'm going to extend this. Okay, without, if you don't know the formula and you want to use the diagram, this is how you get your back bearing. Okay, I know this is what I have. Okay, so this, it will be 180. Do you agree? Do you agree that from here to here will be 180?
Yes, please.
Okay, now do you also agree that the angle here will be the same as the angle here? This angle. Do you agree? Okay, if you don't agree, let's look at this. Always, okay, your north-south lines, okay, will be parallel. Do you agree? You agree, and your west-east lines, okay, will equally be parallel. Do you agree? So if I have my north-south lines, so let me equally extend it so that maybe the south will come in for you to appreciate. So this line here and this line here, they are parallel. So if I have a line joining them, that line becomes a transversal. Okay, so any angle that is here will be the same as the angle that is here. And what will be the type of angle that you can mention there? Okay, the Z shape. So that will be the alternate angles. Is that clear?
yes,
Okay, so alternate angles are equal. So I don't need a rocket scientist to tell me that this is 130 degrees. So it means my overall angle, which is the angle made from this line to this line, the whole of this, will be, okay, 180 plus 130, which is the same as the, okay, your theta. So you add 180 to the 130. That's where the formula is coming. So you don't, if you know the formula, you don't need to draw the diagram. Once you are giving the back, the forward or the front bearing, you should be able to get the back bearing straight away without, okay, drawing. Okay, so please take note. So let's move on to the actual, okay, question. Okay, I was going to look at it from the other perspective as well. So let me equally do same. Assuming the other one was the forward or front bearing. Okay, so I'm going to clear the whole of, okay, all right. So now, assuming that your forward or front bearing this time around is what? A from B. A from B. This is your, okay, forward or front bearing. Then you want to get this time around B from A. So that becomes the back bearing. And you can see that here, if this is our front bearing, so this time around, our front bearing, FB, which is the theta, is equal to what? 310 degrees. And 310 is greater than 180. So it means your back bearing will be equal to, remember we said it will be theta minus 180 if your forward or front bearing is greater than 180. So that would be theta, which is 310 minus what? 180 degrees. And obviously that gives us what? 130 degrees. So you see the validity of what? The concept or the formula that you have here. My point well made. Okay, so if you get this, then let's go and look at some worked example in terms of what the back bearing. Okay, so let's read the first question carefully. The bearing of y from x is 320 degrees. Okay, find the bearing of x from y. So obviously, we are looking for the back bearing because we swapped, okay, the points. Basically, we are going back. Okay, now we said, if you have this situation, your work is going to be very easy. So your presentation, you know. Okay, so now let's go and do, okay, the solution or look at the solution. So solution to question 1. Okay, in this case, bearing, given bearing of what? Y from x. That is your forward bearing. That's equal to what? 320 degrees. Okay, so indirectly, you know that this will be your theta. Okay, but your back bearing, okay, so let me put it this way. You will know. So that I don't go back in. So, but, okay, bearing, I know the back bearing of x from y, okay, which is equal to the back bearing, will be equal to, remember we said it will be theta minus what? Okay, 180 because it's greater than 180 degrees. So that will give us what? 320 minus 180 will give us. I hope you are following, my professors. Are you following? Do you get my point? This is theta. This should also be theta. Okay, let me draw it well or write it well. Okay. Oops, I don't know if okay. All right. So that gives us 140, right?
Yes, please.
Okay, so 140, don't forget your degrees. It's already 3 digits, so you leave it like that. Okay, then you can come and draw your conclusion, therefore, or as you are smart, you can write the therefore here. Then let's go and look at 2. Okay, 2, the bearing of B from C is 062 degrees. So bearing, okay, of, okay, B from C, okay, is equal to what? Is equal to, what do you call, this time I'll present it a better, okay, or matured way. Okay, so I'll write there for, okay, the bearing of C from B, which is the back bearing, okay, will be equal to, I know, because this is less than 180, I will add, okay, 180 to this. So it will be 62 degrees plus 180 degrees. Okay, the formula is embedded in this. So instead of quoting the formula in terms of theta, I can quote it in terms of specific. So that gives us what?
242.
Okay, 242 degrees. Don't forget. Alpha. Hello, is my point well made? Are you all following?
Yes, please.
Okay, so now, well done if indeed you are following. The third one, we'll do all of them because they are differently put so that you know exactly what to do in, okay, all situations. So 3, okay, what are we giving? Vector PQ is equal to, so you can, if you're giving vector in the magnitude bearing form. So 10 kilometers, which is the magnitude, and the bearing 060 degrees. What are you supposed to find? QP. So you can see that QP, you are going backwards. Is that not it? So QP vector must also be stated in the magnitude bearing form. So I can say that therefore, okay, the vector QP, okay, will be equal to, whether you are moving from P to Q or Q to P, you know that, okay, the distance will be the same, true or false. Okay, so obviously true. So the distance automatically becomes what? 10 kilometers. Now your forward bearing or front bearing you know it is less than 180. So it means your back bearing will be 180 plus this. So that will give us what? 240.
Yes, please.
Okay, so you are that as simple as that. So you can look at it and state it. Anytime you are given a forward or front bearing and you are asked to find, okay, what do you call it? Now let's look at this one as well. Okay, very interesting. And I will give you a very simple way to make that determination. I think I will even give it to you straight away. Okay, without going, okay, the normal route. Okay, so a ship is on the bearing of this from a lighthouse. What is the bearing of the lighthouse from the ship? So you can see that we swap the positions. So we are going to look at, what do you call it? The back bearing again. Only that this time round, your given bearing, which is the forward or front bearing, is in the compass bearing form. Your first three were in the true bearing form. So once your bearing is given in the compass bearing form, any other bearing that you are asked to find must also be stated in the compass bearing form. All correct? If possible. Okay, so now this takes us to the form. Okay, it is very easy. Okay, I will give you the trick, and that's all. Usually we'll derive it together, but I will just throw the trick at you. So now what do we have? What are we giving? So we are giving bearing of what? Shape. Okay, so shape. Okay, from a lighthouse. Okay, so let me write it well. Okay, in any case, you can hear. And that you are told is what? South, okay, 65 degrees west. Okay, that's what you have. And please take note, if you want to find the back bearing, which is the bearing of what? The lighthouse from the ship. Are you following?
Yes, please.
Okay, ship. Okay, will be equal to, when you are dealing with compass bearing, anytime you are asked to find the back bearing, okay, this is it. This is the trick. Okay. So always you are going to get this, either this, north theta west or north theta east. Okay, and again, you will have either south theta west or south theta east. Is that clear? That would be the possible, okay, nature of what your compass bearing, okay, forms. Okay, anytime you are looking for the back bearing, if it is north, the north changes to south. If it is west, it changes to east in the back bearing. So here, the back bearing of what we have here will be, because this is south, the south changes to west, sorry, north, forgive me. And the angle will be maintained, 65 degrees. And your west will change to the opposite, which is what? East. As simple as that. Should I come again, or my point is well made?
Please come again.
Okay, so my point is, anytime you are given a compass bearing angle, okay, and it is required that you need to find the back bearing. So meaning your forward bearing is in the compass bearing form. The back bearing equally must be in the compass bearing form. And I said you can get the back bearing without necessarily drawing for you to go back. So if you were supposed to draw, then this would have been the situation. So if you had drawn, okay, we said south, 65 west. This is west. This is south. Okay, north, east. So south, 65 west, this is what we are going to get. So you move from here. So assuming your reference point here, what is your reference point? It's from the lighthouse. So let me use L to represent the lighthouse. So for me to locate what? The ship, I need to move 65. So 65 will be closer to the west than to the south. So this is the 65 degrees. So assuming this is where my Okay, I'm going to draw this. This is where my shape is located, so S, to represent the shape. So this time around, I'm looking at what? From the shape, okay, to the lighthouse. So it means I'm interested in this line. And if you look at this line, you move from the south, in between the south, sorry, the north, forgive me, and the east. Can you see that? So it means my bearing will be north something degrees what? East. But if I want to look at north, I have to move a particular angle here. If this is 65, remember this line and this line will be transversal. So these two angles will alternate. So the angle here will also be 65 degrees. So it becomes 65 degrees. I said, don't stress yourself. You can do without this diagram. Immediately you see south, something, okay, just keep your angle between them, then change your cardinal point, each of them to reflect its opposite. Opposite of south is west. Opposite of south is north. Opposite of west is east. Okay, so in that same vein, assuming maybe I gave you this north, okay, 40 degrees, okay, east, and I asked you to find the front bearing was this. What do you think the back bearing will be? In terms of the compass bearing. Based on what I've said, what do you think the back bearing will be?
In south.
South.
South, the whole class. 40 degrees, you keep your angle, then this changes to what? West. As simple as that. You get it?
Yes,
Okay,
please.
so
Thank you.
very good. You are welcome. Okay, so now this is it for, okay, the back bearing situation. We'll look at it, okay, we'll use it later, okay, going forward. Now let's look at our next, okay, concept, work this out. So it's now that we are going to begin, okay, dealing with bearing, okay, because usually you'll be drawing, and out of your drawings, you need to go and calculate or look for your bearings. Okay, so let me see. All right, so at this point, we are going for a water break. When we come back, we'll make use of all that we've learned, okay, to deal with, okay, whatever that we have there. Okay, so we have, let me see, how many minutes will I give you? Okay, so I think I'm giving you 3 minutes. Okay, so by 5:10, you should be back. Okay, so welcome back from the water break. Okay, so let's look at these questions and how best to deal with them. So what is the task? We are supposed to calculate the 3-figure bearing of the following. So in that way, you are supposed to find the true bearing. Okay, so with the first one, we are looking at the bearing of what? J from K. The bearing of J from K. So your reference point is what? Is K. Hello, are you with me? Okay, so if you want to find the bearing, are you with me? My professors, are you with me?
Yes, please.
Okay, great. So if you want to find the bearing, this is what you do. Okay, the bearing of what? J from K. It means you stand at K. Your bearing angle must be between the true north at K and the line joining your 2 points of interest, which is what? The point J and K. So it means I'm looking at what? The angle here, the angle between this true north and this 2 points of interest, the line joining them. So I'm looking at this angle. Is that clear? Hello, are you with me? Do you agree that this is the angle that we are looking at? Okay, so if this is the angle that we are looking at and you agree, you know that, okay, the north lines here, okay, will be parallel. So this becomes a transversal, and you are told that the angle here is what? Is 180. So you should know by extension, the angle that we have here will also be what? 100. So this angle here is 100. You should know that this angle is also 100. And that's the angle that you are looking for. That will form the bearing of what? J from what? From K. So in that case, I can say that the bearing will be equal to what? 100 degrees. Is my point well made? Or I should come again? Hello, is my point well made?
Please come again.
Okay, all right. So remember I just said, anytime you're asked to find the bearing and angle is an angle, and angles are formed between two lines. So you should know your lines under consideration. Okay, and I said automatically one of the lines will be your true north because that is your reference line. Bearing angles are measured from the true north line. So it's the true north line that you move clockwise. Okay, but you move clockwise up to where? Up to where you have the line joining your 2 points of interest. So here, my true north, I move clockwise, but where do I end? I end on the line or at the line joining my 2 points of interest. So here, my points of interest will be J and K. Is that clear? So it means the angle from the true north clockwise up to this line. So I'm looking at the angle here. And like I said, anytime you have two power lines, okay, plane geometry 1, okay, power lines and their properties. So if this line is parallel to that, immediately I have a line joining them. Okay, I have a transversal. So if I know the measure of this angle, I know the measure of this angle and vice versa, because it will give me the Z shape, okay, angles. So this angle will also be equal to this alternate angle. So here, my angle here, if you look at, you are in the diagram, you are told that the size of this angle here is 100. That is from here to here. Okay, so that will give you 100. Somebody equally can come and extend this. Okay, and but only that you will do more work. And you will say that because this line is a transversal, this and this, okay, will be co-interior angles. Co-interior angles add up to 180. So if you know this angle, you know this to be 80. But 80 is not the angle that you are looking for. You are looking for this angle rather. So angles on a straight line should give you 180. So it will be 100 minus what? 180 minus 80, which will give you 100 here, which is the same as you using the alternate angles directly. So if you go by the other route, you get the same answer, but you do more well. Is my point well made now? So always, okay, alternate angles will be formed. So look out for the alternate angles and how easily you can find them. Okay, so now that will be it for the 1. Now let's go and look at 2. The bearing of H from F. So our reference point is what? Is F. Okay, and remember it's going to be the angle between the true north and the line joining your point of interest, F and H. So it means we are looking for this angle. Is that clear? Is my point well made? Okay, now if you look at what we have here again, you can see that we have two power lines. Okay, and this is a transversal. That transversal is extended. Okay, and an angle is formed here. You can see that this angle here would be the same as this because you form a corresponding angle. Is that clear?
Yes, please.
Okay, oops. Okay, so it means my bearing, okay, there will be what? 34 degrees. Am I right? Hello, am I right?
Yes, please.
No. Bearing angles must be how many digits?
3.
3. Okay, so take note. It should be 0, 3, 4. All correct?
Yes, please.
Okay, all right. Now let's come to, okay, this one. I think I should leave it for you to try, okay, later. Or we have more anyway, maybe when we get there. Then, so with this one, we are looking at the bearing of what? D from C. So your reference point is this. This one, I think you do a little more work. Your reference point is C. So you are looking at the angle between the true north and the line joining C and D. So you are looking for the size of this angle. That's all that you are asked to find. All correct. Is my point well made? So you can play with it. You're playing geometry 1, okay, concept, okay, or knowledge. And here I am going to play with it this way. Okay, once I know that this is a transversal, okay, and these two parallel, I know that the angle here will be the same as the angle here. Do you agree?
Yes, please.
Okay, so that will give you 1, 2, 2. So now at C, I'm looking at angles at a point. So if I subtract 1, 2, 2 from 360, that will give me the angle here. All correct. Or I should come again. Remember the bearing angle that we are looking for is this one. Okay, from here up to this. So if I know the size of this angle, angles at a point will give me 360. So it means I need to subtract, okay, 1, 2, 2 from 360, which is, okay, 1, 2, 2 is the size of this angle, because this will also be the same as 1, 2, 2 degrees. Okay, however, somebody equally can do this. Okay, I am going to bring the picture down here. Okay, and use it to do my analysis. Okay, so this is the situation. Okay, you are told that this angle here is 1, 2, 2. Okay, somebody can do this. We are looking for the entire angle here. I can extend this. If I extend this, I know that this angle and this angle here, okay, will be co-interior angles. They should add up to 180. Do you agree? Okay, we didn't write the value there, so let's write the value. We've answered the question, so let's write the value once you know that we are done, only that we are looking at an alternative way. What did we get? 360 minus 122. Come again.
238.
238 degrees. Already 3 digits. Now let's come here. Okay, you are going to get this plus this should give you 180. So it means this would be 180 minus 122. And that will give us 180 minus 122.
58.
Okay, 58. Okay, so once you have this, you know the angle, because you know that from here to here will give you 180. So you come and add, because we are looking at the entire angle here. So you come and add the 58 to this. So that will still give you 180 plus 58, which is 238. So you get the same result. Is my point well made?
Yes, please.
Okay, very good. So now you come and do same analysis here. The bearing of R from S. So from S, okay, as for this one, it's basically the same as almost this one. Only that, okay, you can see that the picture has been turned. So it's this angle, okay, that if you are able to find, but that's not the angle that we are looking for. If you know this angle, you know the entire angle. So here, the bearing of what? R from S is this angle from here up to here. Do you agree?
Yes,
Remember,
please.
the bearing must be from the true north, measured clockwise up to your line of interest, which is the line joining the two, okay, points. Okay, that you are dealing with. So again, I know that if I'm able to get this angle, the total angle here will be 360. This angle I know, okay, you know, corresponding angles. So 49 degrees. I subtract it from 360, then I'll get this. You come and write it there. As simple as that. Okay, so we can move on to the next one. Okay, all right. So we need to work out the bearing, okay, that we have there. And I think maybe you do 1 or 2, the rest you go and try. So with this one, okay, the same way, this is 68. Okay, and if you look at this, okay, I can confidently see back bearing in play. If you look at this from here to here, now I'm moving from here to here. So I'm going back. So I can get the back bearing straight away by using the back bearing technique. So it means here I am going to get the A that I have here will be 180 plus 68, or 68 plus 180. Do you get the point? Or if you don't want to use the back bearing and you want to use what you've been doing, you know this angle, because these two angles will be co-interior angle, parallel transversal. So you know the sum should give you 180. You subtract this from 180, whatever you get, you subtract it from what? From 360, and that will give you what you are looking for. Okay, again, now we use the back bearing. Okay, that's the front bearing, the back bearing. Okay, front bearing, back bearing. So you should know that always your front bearing and the back bearing, if you add, you should get a 360. Okay, so if you know this, subtract it from 360, then that will give you, okay, the angle that is here. But remember I said, okay, front bearing known, less than 180. So back bearing would be what? 180 plus this, rather. Okay, as simple as that. Are we good to go? So you can try your hands on what? On the rest. Okay, all right. So quickly, let me see whether I can use the remaining time, okay, to deal with. So now actual, we are going to deal with actual questions. Okay, the usual way that bearing questions will come. Okay, so take note. I believe all of you have done trig. Is there anyone here who has not done trig in core maths? Okay, we thank God. If you have done trig, then we'll make use of certain trig, okay, concepts, okay, here. So we'll follow on that as and when. So here, let's go and look at the solution to these questions. Question 1, I'll read it on the solution, okay, page. So the bearing of 2 points, okay, is supposed to, the bearing of 2 points is supposed to be 2 points. Q and R from a point P. Okay, so quickly, let me go and do the needful. Okay, before maybe I forget. Okay, I can do the changes later. Okay, so from a point P, so all of them, they are taking their reference point from P. Okay, the angles are measured from P. Okay, the bearings are this and this respectively. If the length of PQ, so the distance between P and Q is 34 kilometers, and the distance between P and R is 18 kilometers, find the distance QR. So take notes. So this is what we are going to do. Okay, our work is going to be a little easy, okay, from here. All right, so anytime you have a bearing questions where you have 3 points, remember we know how to draw diagrams when we are given 2 points. Because in terms of the bearing and the distance, always you have 2 points. So if an extra point is given, it's basically the same thing. Okay, only that later you join the 3rd point, okay, the missing line, okay, to get a particular figure, which will always be a triangle. And that triangle will either be a right angle triangle or a right angle triangle. If your diagram gives you a right angle triangle, you thank God, your work is going to be easy. Okay, whether you are finding bearing or you are finding, okay, distances, you should, okay, be happy. However, if it is not a right angle triangle, still you don't have to be worried because you have a way of dealing with it. Okay, only that you will do a little more work, that's all. So quickly, let's go and look at exactly what we are going to. We need to draw. However, we are not drawing to scale, but it should still make sense. So I will go back to my normal, okay, view because I will need my straight edge. Okay, so here we are. Okay, and please, once again, anytime you are dealing with bearing question and even construction question, okay, don't be in a hurry. Always get a rough picture. And the rough picture shouldn't be that detailed. Your rough picture will tell you the area of your page that you need most. Before you start drawing lines and you realize that no, okay, you didn't position your points well. Therefore, you have to go and erase, and that will be time wasted. Okay, so now what do we do? Let's go and get a rough picture. So I have this, okay, a rough picture, and usually in pencil. Okay, so I'm doing it something small. So I have a point P. Okay, my Cartesian will be there, north. Okay, from P to Q. Okay, the bearing is 30, so it will be here. Okay, so this is P. My Q will be somewhere here. Okay, then, okay, that of R is 120. Okay, 120 will be somewhere here. Okay, the distance between them, PR, okay, is okay shorter than what PQ. So it means this should be a little longer. So in this case, I know the area, okay, of my page that I will need. I don't know. Do you get my point? So this tells me that I will need, okay, this side more rather than this side. So I'll start my diagram from this point. Okay, this is exactly what you need to do, okay, before you start. So I am going to draw. And anytime you are drawing, okay, please take notes. I usually advise you use 4 lines, okay, in terms of your Cartesian lines. So you will be drawing in lines. So let's say you have this. Okay, so draw your west east line here and the north south line here. Then you can see that it will be this would, once you draw this one on the line, you know, you are sure that it is what horizontal. And this one too will take, okay. And as you are drawing, make sure your lines will look, okay, I'm talking about north, south, and east, west. They will look, okay, horizontal and vertical. Okay, take note. So in this case, that is exactly what I'm going to do. Okay, I'm going to draw it here. I know where I will need most. I will need a down because a certain line will go down here, and I will need a line up here. So I will go a little up. If you come down and you need a line there, okay, problem. So I will go a little up. So this is where I will draw. Okay, so indirectly I've covered my 4 lines. Okay, then I come here, it will midway my 4 lines. Don't forget that. So that is going to give you, okay, I'm going to do this. Okay, and your, what do you call it? Cardinal point of interest will be the true north here. That is the only cardinal point of interest. Okay, so now what are we going to do? Okay, we are going to bring in the angles first. So this point here, your reference point, all the other points, okay, measured from P. So let's go. From P to Q, the bearing is what? 30 degrees. My professors, are you following? Are you following my professors?
Yes, please.
Okay, good. So you're 30 degrees from the true north. Okay, 30 degrees. So it means the 30 degrees line that we are going to draw, though it's not drawn to scale, you know, it should look closer to, or it should be closer to the north line than the, okay, east line. Okay, so take note of that. So at that point, maybe this is what I'm going to do. You shouldn't go beyond the midway line, which is the 45 degrees. So 30 degrees, that's what I have. I want to bring out the picture clearly. Immediately you are able to consider these, okay, vital information. Your work will be very easy going forward. So in this case, I'm going to draw, okay, my 30 degrees line. So indirectly, that's what I have. That's the longest line. Okay, so I can end there. Okay, the other one will be shorter than it. Okay, and you can see that this line PQ, the distance is almost twice this. Do you agree? Or it's more than twice? Hello, I want to see if you are with me.
This is less.
It's less. Okay, 2 less. Is that not it?
Yes, please.
Okay, so it's
Yes,
almost twice. Okay, so now this is the longest. So you hold on because, okay, it will give you, if it is too short, the other one too will be very short. Okay, so now this is where maybe my point Q will be located. Okay, and anywhere my point is located, I will indicate my cardinal point there because it's very possible I will need it to measure bearing. So I will indicate my cardinal, okay, points, okay, also there. And when you are drawing, make sure your lines, horizontal lines are horizontal, vertical lines are, okay, vertical. So in this case, again, I will need my true north here. Okay, and my point Q, let me see whether the other line, okay, so I can indicate my point Q anywhere here. So I'm going to indicate the Q here rather. So let me go back. Okay, so Q will be here. Then now I indicate the bearing angle must also be indicated here. The bearing angle here is what? The 30 degrees. So you indicate the 30 degrees, very important. Okay, then when you come here to, okay, you indicate the distance, and that is what? The distance between P and Q is what? 34 kilometers. So you write 34 kilometers along it. But unfortunately, I cannot do that. So, so 34 km. So I will not write along it, but you will write along that. Okay, now let's move on to the next bearing and the distance. The bearing is 120. Okay, also from P. So you know that 120, this is what you are supposed to get. Okay, from here to here. Okay, let me see. From here to here will give you 90. Okay, you want to get to 120, so you need 30 more, am I right? So
Yes.
30 degrees from here to here. Will the line be closer to the west, sorry, to the east or to the south? Will it be closer to this line or this line? Obviously, this line. Okay, so we have to make sure it reflects so. Okay, though we are not drawing to scale. So here I'm going to draw my 30 degrees somehow. Okay, line. But this line, I know, should be a little more than, okay, is it? Yes, a little more than half of that. Is that not it? Half of this line. If you do that, okay, so a little more, the picture will come out, okay, clearly. Otherwise, okay, so assuming maybe you ended somewhere here, okay, you know the picture that will come out. So consider the distances as well as the angles. Once you do that, your work will be very easy. Always, okay, check the relationship between the distances, okay, and the angles, their sizes. Once you get that, like I said, the work will be very easy. So here I am going to stop at this point. I could have even stopped here because it's like I'm looking at almost half of, okay, or a little half of that. So I can even stop here. Okay, but it shouldn't be, remember I said, it shouldn't look, just make sure that it doesn't look more than what you have here. And indeed, that's what I have. So I can fix my point here. Okay, then now, okay, what do? I indicate my cardinal point there. Something will come out, okay, shortly. So please, let's see what the picture will be going forward. So I indicate my cardinal point. All the points there, cardinal point must be indicated. I mean, your point of interest, okay, because it's possible you'll be asked to find the bearing using that point as the reference point. Okay, so now I can draw this line as well. Okay, so at this point, I have my third point, and the third point is what? R. Okay, so remember, don't forget to indicate your true north. Okay, and any angle that you, okay, considered, yeah, you consider the angle 30. Okay, let me move. So the angle here will be 30 degrees, indicates that angle. Okay, so now you know the distance is 18 km. This time around, I can write along it. Okay, now the other one, okay, we've considered. So you come and join, I've not indicated my point R. Okay, so R will be somewhere here. Okay, so I join my Q and R. So let's join that and see. Okay, I guess you are also practicing. Okay, so if I join, look at the picture. Okay, so this is the picture. So you can see that once I have 3 points, When I join all the points, I will get a triangle. Okay, so take note. So this is the situation that we are looking at the moment. Okay, so, okay, I'm going to rule a line here. We'll go and continue. Okay, so I'll take this side. Okay, so I'll go and continue there. As my next page. Is my point well made? At this point, please, who is not with me? Okay, your diagram is key. If your diagram is wrong, everything will be wrong. So make sure you get your diagram, okay, reflecting the true picture. Okay, so now at this point, we are in a comfortable lead. So this is all that you need to do. Always one of the interior angles will be known. And I repeat, always one of the interior angles will be known. Okay, so if you look at it clearly, you can see that it is this interior angle that we can easily find. So this is 30. So you know that the remaining angle here, if this is 30, the remaining angle here will be 60. Do you agree? So it means the angle here will be 90. So I'm dealing with a right angle triangle. Okay, sort of. So immediately you do that, you realize the type of triangle. I will plead, please pick it out. Okay, come and draw it beside it. Pick only your triangle and your point of interest together with, so without this time you are going to draw without a cardinal point. Okay, because what we have there is busy. Some students can use this directly, the diagram directly too. I will advise, okay, do this. Pick out your triangle and come and draw it beside and use that one instead to do your analysis, especially when you are dealing with what certain angles and okay size of the triangle that you need to find. So I'm drawing my right angle triangle because I know that it's a right angle triangle. Okay, so it's right. And for every right angle triangle, your duty is to locate, okay, the point that your triangle is right at. Okay, so you know, you just have to wait for the video, princess. Okay, you don't take us back. All right, then you watch. So in this case, this is what we have. Okay, your triangle is right at P. So just indicate your P. Your two other points, which will be Q and R, you can put them anywhere. So let me say maybe Q is here and R is here. Somebody can put R here and Q here. It will not change anything, any of your calculations. It's only where your right angle is that if you change the point, there will be issues. So now after doing this, go and indicate all your known size. So I know PQ, and that is 34 km. Okay, which one too? I know PR, and that is what, 18 km, kilometers. Is that clear?
Yes, please.
Okay, so now if this is the case, then okay, let's go, and we were asked to find the distance QR. So we are finding this distance. So let's go and quickly find, okay, that's distance. All right, so at this point, I think this can go. Let me clear it. Okay, then I'll need the space to deal with whatever that I'm going to write. Okay, so once you have a right angle triangle and you know the measures of two of the size, we thank God because of angle pita, okay, we can get what a formula that will help us easily find the unknown side. Okay, so in this case, you come and write, okay, you want to find this. Okay, we are going to use the Pythagoras theorem because we are dealing with a right angle triangle. So you write by the Pythagoras theorem. I've told you, if the formula is named after a person, write it, okay, appreciate the person before you move on. By the Pythagoras and its possessive, okay, theorem. Okay, you know that we said the distance QR squared, okay, will be equal to, okay, it will be equal to the squares of these two sides sum. So I can write, okay, 34 squared plus what? 18 squared. Is that clear? Okay, someone who is more matured will quote the Pythagoras refined version. So the person can write QR straight away. Okay, will be equal to root of, then come and deal with that one. It's the same thing. Okay, only that the person will quote the refined version other than the raw one. Okay, so in this case, what are we going to get? This will be equal to, hey, let's go. 34 squared. I'm waiting.
1156. 1,156.
You said what?
1,156.
Okay, so
1156.
okay, 1156. Okay, you said 1156. Okay, then plus, okay, 18 squared will give us 324.
324.
Okay, so 324. Okay, so in effect, we are going to get this one, okay, plus, so 1156, okay, plus 324. I'm waiting. 1480. Okay, 1480. Okay, but that will be it. We are not looking for QR squared. We are looking for the length of QR. So I will say that the length of QR will be equal to root of what we have here, 1480. All correct. My
Yes,
professors,
please.
are you
Yes,
following?
please.
Okay, so let's see whether the question asks us to approximate, if it requires approximation. Okay, so what did you get?
38.470.
Okay, and at this point, I will plead. If the question didn't ask you to approximate, don't take it to decimal place because you can get its actual or exact value. Okay, feed your calculator with this. Your calculator should be able to, okay, if this set is not in its basic form, your calculator should be able to give you the set in its basic form. Otherwise, your calculator will throw it back at you, trying to tell you that the set is already reduced. Okay, it's already in it. So please, okay, do the needful. I'm waiting. What did you get? In terms of said. Okay, very good.
370.
Okay, very good. So you are going to get, okay, 2. So this would be equal to, okay, so maybe I can write therefore my conclusion, the length of QR, okay, would be equal to 2 roots what?
370.
Okay, 370. Is that all? No, Princess, who doesn't like units? Okay, you know, there is a unit here attached. Okay, don't forget. Very important. So you are done. So you have given the exact distance. Okay, if the question wants you to approximate, we will tell you to approximate. Otherwise, unless maybe you want to use this, even if you want to use this, you can use the exact value here rather than the approximated one. Is my point well made?
Yes, please.
Okay, any questions at this point before we go and look at our next question? Okay, we thank God you are all fine. Now, here comes our next question. Okay, question 2. Okay, I'm going to help you draw the diagram. Okay, maybe, okay, with this time, you can see, you are asked to find the distance. I will ask you to find the distance because after the diagram, you should be able to, based on the first example. Then the bearing, we come and do it together. So quickly again, okay, we are going to draw. And I said, anytime, don't be in a hurry. You should, anytime you enter the exams hall, you should know your plan of protecting your mass. You should have a strategy. And you know, I've told you, a strategy should always be, I am going to be very particular. anytime I read question, I underline the salient parts. So meaning I would pay attention to detail to protect certain low-hanging marks. Okay, then after that, I know all my tricks and I'm not in a hurry. Okay, the fact that we finish first doesn't mean you score more than me. No, it doesn't always mean so. Okay, so in this case, what do? I am going to, okay, get a rough sketch. And I've told you, your rough sketch shouldn't be, okay, you can use your free hand, it's a sketch. So what do you do? Yeah, I'm looking at the bearing of O, okay, A from O, because that's your, and that's the distance is this is the bearing. And all this 1, 2 takes it. So I'm looking at a point O. My cardinal point there, O. Okay, the first one, the angle is 130. That is from O to A, 130. 130 will be somewhere here. And the distance is 15. Okay, that's the shortest distance. Okay, and the other one, okay, what do I have? O to B, okay, 25. The bearing is 220. 220 will be somewhere here. Okay, then that distance will be more than that. Okay, so I know I will need, okay, this side of the area more. So when I'm placing, because I know one line will go this way, this line will be longer than the other line. So I will need this side more. Okay, but my point should be located somewhere here. Now that I have the rough picture. If you don't take care, you come and start from here, you know that you didn't get a space to draw the other line. So at that point, by then you would have drawn your lines. So what do? That's more time that you could have used to think. Okay, you use more time to clean. You get the point. So always get the rough picture before. You should always have a strategy. Okay, and I'm giving you all the strategies. So please make sure you adapt. So now we know what to do. So we are going to fix our point P somewhere here. Okay, so P. Okay, I am going to fix you here. So somewhere here, midway up here, because I will need, okay, so let me go up. I will need, okay, the down more. As for the up, I won't need anything. So let me go up more per my picture. And I've told you 4 lines, okay, there. So make sure your lines look horizontal and vertical so that they will look parallel. Okay, so now true north, my original point, okay, all points of reference, O. Okay, so now let's go. Okay, from O to A, the bearing is 130, so this is 90. 130, I need how many more? I need 40, right?
Yes, please.
Okay, you know 40 is supposed to be closer to, okay, this line or this line. Is it the east line or the south line? It's supposed to be a little closer to the east line, so please take note. So we go and draw. Okay, almost midway. Okay, so 30, I'm looking for the 30. Okay, so at this point, what do I do? Okay, so, it is 40 rather, not 30, forgive me. I'm looking for 40, which is a little close. Okay, I have my, okay, straight edge giving me, but you can see that I just want to deviate a little from the straight edge. Okay, other than that, it's like I have a helping hand. Okay, so the distance there is 15. That is shorter. Okay, so immediately I can see that I'm going to have a bigger picture. I can end here. Because immediately you make this one long, it means the other one is going to be very long. You get a point. So I think this is long enough. It's okay. Okay, this one is looking like almost twice. Okay, this 15, 30, almost 30. So almost twice. Okay, so now this is what I have. Okay, now I'm going to indicate my angle that I added 40. Remember, I've told you any angle that you added to get the actual bearing indicates 40 degrees. Then indicate your point as well. And what is your point? The point here is a point A. And go and again draw your, or indicate your Cartesian, the cardinal points there. So I come and indicate my cardinal point also at that point of interest A. Okay, well, I will indicate before I will put my A there. So my A, by the nature of the diagram, okay, I know my A can be here. It will not interfere with anything. So A will be here. Okay, and I don't forget to indicate my true north. Very good. Okay, so now what are we supposed to do? We need to move on, okay, to the next, okay, vector. Vector OB means our reference point is O. Okay, so the bearing is taken from what? O, your initial, okay, your terminal, remember. Okay, so now what do we have? Bearing 220. So still from O, bearing is 220. So I will measure, okay, from here up to this is 180. If I want to get to 220, okay, I need how many more?
40.
Okay, 40. So I am going to add 40 again to that. So 40 will be closer to that line than to the west line. Okay, but almost midway, because midway is 45. Take notes. Okay, so at that point, but I shouldn't go beyond. At that point, let me see, it's not going to pass through the exact middle. Okay, so this will be better, but let me see if I can tilt it a little. Yeah. Okay, so now I will draw. But this line is longer than the other line. You're supposed to look almost twice. Okay, so longer than that, I will end there. Is it looking like more than twice? If it's looking like more than twice, then you know what to do. Okay, so in this case, I am going to get what I have there. Indicates. Okay, so it's like I found my point B. Okay, or I now know where my point B is. So I am going to, okay, draw my cardinal points at all the points. Okay, so you're not here. Okay, remember we added a particular angle. We said we needed 40, so this is 40 as well. Is that not it? Is my point well made? Okay, and this is your
Yes,
point
please.
B. Okay, you indicate it here. So now remember, you should always join, okay, these two, okay, points. The last, when then a triangle will be formed. So, oops. So let me come and do the needful. This time around, it seems my straight edge is giving me cause to worry. Okay, so let me use my one hand and see. All right, okay, it's better. Oops. So by now you should be done. Okay, a certain angle. Okay, so I will manage like that. I think this one will be quite perfect. Okay, all right. And remember, we didn't indicate our distance is very, okay, important. So this one is 15, okay, km. Okay, however, the distance here, okay, is what, 25 km. Okay, and remember I said always one of the angles will be known. So this is 40, the whole of this is 90, so this is 50. Do you agree? So it means the whole of this angle will be 90. All correct. Okay, so wherever you have space, if maybe, yeah, I know I'm going to take this as my next page. So let me rule the line there, and that's where I'm going to do my calculations. So at this point, I'm going to indicate the triangle here, the right angle triangle. I'm going to draw it here. Okay, and always I've told you, use your straight edge. If you have a space here, okay, draw it beside it. If it's below, draw it. Draw it somewhere that you can easily see, use it to do your analysis. Okay, only that I usually do it beside. Okay, but because here I am solving in columns and I have indirectly ruled a line to cater for that space. Oops. Okay, so you come and join this one as well. Okay, what is happening? Okay, so now I join this, which will give me my right angle triangle. Okay, so quickly. Okay, this is the 90. And remember I said fix where you have your 90, and that is O. The other 2 points, you can fix them anyhow. So maybe A, then B. Let's indicate the known distances. Okay, OA. Okay, do I know? Yes, that is 15 km. And I know OB, that is 25. OB is 25 km. Okay, so at this point, I'm waiting for you to find the length of AB. Okay, so you know Pythagoras theorem, so go and find it. Okay, by the Pythagoras theorem. And it's capital P, take note, it's the name of a person. Okay, now I know I am going to put the refined version. If you are not matured, put the raw one. So that will give us what? The length of AB will be equal to root of, okay, I know the sum. So the AB here is the hypotenuse, and that should be equal to the square of the other side. Okay, plus the square of what? 25. Okay, so continue for me. I'm waiting for your results. So therefore, the AB length will be equal to this one. You are not asked to approximate. After that, then we come to the bearings. Because of the bearing angle, that's okay. I am still with you. My professors, are you there? Hello, my professors. You are too quiet for my liking. Is everyone okay? Are you following?
Please, we are here.
Okay, you are following.
Yes,
Okay, great. Please, I've told you, don't hide your issues once I'm here. All right, so I'm waiting for the answers. Okay, I mean the answer here. Come again.
34.
5
with
34.
with 34. Is that
With
your answer?
34.
Is that all? And it's Pythagoras,
Yes,
it's
please.
possessive. Hey, princess and unit.
No,
She doesn't like unit at all, princess.
KM.
5 with
Okay,
34.
KM. Okay. All right, so please take note. So now we are going to look for the bearing. And the bearing, we are looking at the bearing of what? So give me some few seconds. Let me be with you, okay, to find the bearing. Okay, so now, okay, I think we can clear what we have there to create room. We are going to look at the bearing. Oh, I didn't pick the eraser. Okay. All right. So now we are good to go. Okay. All right, so the bearing. Let's go and look at what we have there. And I think the bearing, I don't need the straight edge. Okay, so I can let it vanish. Okay, so let me do this so that we can have a better view. Okay. All right, so the bearing, we are looking for the bearing of what? A from B. So it means we need to go and stand at where? B. B is our reference point. Is that clear? Okay, so the bearing of what? A.
Yes.
The bearing of A from B. So the angle that we'll consider, we'll look at the true knots, okay, at B or on B, and what's the line joining your point of interest AB, measured clockwise. So it means we are looking at the size of this angle from here up to this. Do you agree? Should I come again?
Yes, please.
Yes.
Okay, remember I told you, whenever we are looking for the bearing, okay, of a point from another point, it means your reference point, that is the from point. Okay, you are going to have a certain angle there, but that angle must be formed between the true knots at that from point. Okay, to the line joining the 2 points of interest. So because the bearing is taken, okay, is taken from the point B. Okay, to be the angle between my true knots at B and the line joining AB, my point of view, because the bearing is A from B. So your point of interest would be AB. always bearing, you use 2 points, you know, your initial and terminal. Okay, so in this case, it is the angle made by the true north, okay, and okay, this line, but in the clockwise direction. You can see that there's another angle here made by this true north and that line, but it's the clockwise angle. Sorry, the anti-clockwise angle. But we are looking at what the clockwise angle. So it means I'm looking at the angle from here to here. All correct? Is it
Yes,
clear now?
please.
Okay, so if you look at it clearly, you can see that the angle that I'm looking for is made up of 2 regions or 2 angles. One of the angles will be here, let me call it theta, one of the interior angles of my triangle. And this angle that is here, I know, because I can see that this is this and this are power lines. This will be a transversal. So if I know the angle here, I know the angle here as well. So can I say that this angle will give me 40?
Yes, please.
You agree? So if that's the case, the analysis that we did there, can I come and write that bearing from the analysis will be equal to 40 degrees plus theta? Do you agree?
Yes, please.
Okay,
Yes,
so if you know theta, we know the bearing. However, you can see that theta is the interior angle, okay, at B of your triangle. So theta will be here. And you can see that because it's a right angle triangle, any unknown angle, you can find it by using the appropriate trig, okay, ratio. So here, you know the opposite of that angle and the adjacent. So what would be the appropriate trig ratio to use here to find theta? You know opposite, you know adjacent.
tan.
Okay, so you come and write tan, okay, or but tan theta will be equal to what? Opposite, which is what? 15 over the adjacent, which is 25. Okay, so in this case, you are going to get what? Theta to be equal to tan inverse of the reduced version of this. And if you reduce this, what do you get? 3 on 5. Is that not it? Okay, so use your calculator to find theta for me. I'm waiting. Tan inverse of 3 on 5. My professors, I hope you are following. Okay, hurry up, I'm waiting.
Is 30.96.
Okay, so 30 points.
9638 dp.
Okay, if she's right, I'm also right, but don't forget your degrees before the 4 dp. She doesn't like units at all, this girl. Okay, dp. All right, so this is what you have. Okay, however, theta is not your bearing, take note. Theta is only a means to getting what your bearing. So in this case, I can write, therefore, okay, the bearing of what? A from B. And very soon I will advise you. That advice is already given anyway, only that I didn't make use of it here. From B will be equal to 40 degrees, okay, plus what? Your 30 point what? 9638 degrees, which in effect will be equal to, okay, 70, and you start it with 0 because your whole number should be 3 digits. 070 degrees, then dot. Oh, sorry, the dots will come before the degrees. Oops, okay. Okay, let me come down here. Okay. My professors, I hope you are following.
Yes, please.
Yes, please.
Great, all right. Okay, so now dot, okay, your 9, 6, okay, 3, 8, okay, degrees. If you want to take it to the nearest whole number, you can, but you can end here, that's okay. All right, that's your full score. Okay, so this will be it for our prelims. Okay, my plan is to use 2 days to deal with bearings. Sorry, yes, bearings. Okay, the first day, target, okay, range. Tomorrow, God willing, we'll look at complex questions. So we saw past questions. Okay, so far we have right angle triangle. Okay, going forward, we'll look at a situation where your triangle will not be this special. Okay, so thank you very much. Unfortunately, I've gone beyond. Okay, so if any inconvenience has been caused, please forgive me. Okay, so thank you very much. Okay, stay blessed. Okay, and God bless us all. Okay.
Amen.